let's take a surface. Let's create a surface, and let me grab a surface here, or let's draw a curve and then just extrude this curve in Grasshopper. So what I would do is grab a curve component, right click to it, set one curve, put this in, and put extrude to extrude the curve. You probably remember this or already know this stuff, so I'm not going to spend too much time on explaining each and every component. So let's say 5,000, which means 5 meters in this end. It might be a bit long, so let's put it this way. So as you know, everything in Grasshopper is shown as preview. So what we are doing here now is basically using this to create sort of a visualization already. But let's say if we want to see this, not this default red color, what we need to do is we need to go first to display, and under display we'll have a tab called preview. So there are some components that are related to showing or previewing the geometries in Grasshopper. We'll be focusing on this one, custom preview. So it requires two things, geometry and the material, but obviously you see that there is no output of this component, which means you are not able to take out information from this component. This is basically created for only rendering purposes. So if I connect this material geometry to geometry, what it automatically does is creates this surface as pink, because the default material is display material defined as this color with pink. How we can change this? We can go to the params, and underneath params we can find color swatch. Color swatch is a dynamic component that shows the colors, and when we put this color into material, it will render this surface with white. So if I right click to this, or if I double click to this, I see this menu pops up, and in this menu I can slide these to left hand side, and then you can see different hues, different colors, different saturation values, different value of between black and the color itself, and the transparency. We can switch this to RGB or hue saturation value and alpha, I guess. Again, the alpha, I guess. And this time you can play around with the RGB values of this component. So this is basically pretty much what we can, obviously we can, if you click on this, we can take out any color that we scroll over now onto your desktop screen, Grasshopper canvas, whatsoever. However, I find it quite difficult to use sometimes, so I usually go with this hue saturation values, and like let's have this purple. And so now what we see is we see our geometry in this color. Let's say, let's create all these different sort of curves, and then what we are going to do is we are going to like extrude them somehow. Let's grab the curve component, and let's say select multiple curves. And what we are going to do is we are going to use their these curves to as our basis to extrude them, right? And when we extrude them, what we are going to do is these are my curves to be extruded. Let's extrude them on Z direction, and let's have this time, I don't know, 1500. And when we extrude them by 1500, you see their heights are the same, okay? And hey guys, if you like this content and if you want to access the exercise files to test on your own, please click the link below to access our school community. And when we see their heights are the same, but there's something different about these curves, right? Their areas are different, or their volumes, their areas are different, not the volumes. So what I can do is I can visualize their areas by using sort of a color, right? So let's imagine the smallest one gets color A, the largest one gets color B. And how I can do that? So what I would need to do is I would need to use their areas as my input, right? So if I go to my area component, I'll grab their areas. But now I need to use these areas. Now they are a lot like they look really large because I'm working in millimeters. But what I need to do is I need to take this area information, sort of remap them and use it as a color output, right? And as you remember, as you see, they get our like midpoint of every single surface. So I can preview this off. The next thing I'll be doing is, since I'll be using color to define these values, I need multiple colors, unlike this one. This has a singular color value or predetermined color value inside of this. But if I grab a gradient, this is my preset gradient or default gradient. So if I grab this gradient, what this component does, based on a lower limit and an upper limit, in which, like, let's say 0 to 1, it ranges 0 to 1 by using colors green, yellow to red, right? But in order to understand the zero value or lower limit and upper limit, I need to understand the lower limit and upper limit of the areas. To do so, I go to math, and under math, I'll grab a component called bounds, as you remember our previous exercise in attractor points. So what this component does basically takes the minimum and the maximum number of these areas. So if I say, how can I extract the minimum and maximum, because now I have the domain that ranges from 1.5 to 3.2. In order to proceed with that, I grab deconstruct domain, because this is a domain, right? This is a domain. And my start is going to be my lower limit, my end is going to be my upper limit. And if I hover over here to my parameter, this is asking based on which parameter I'll be using this upper and lower limit. So I'll be connecting my area here. And then if I go to display and grab my custom preview, and then this is going to be my material, and my extrusions now are going to be my geometry to be viewed, right? So if I preview this off, I'll see colors way better. But what I'm seeing here, you see, they are pretty close to one another, so they are underneath of like the green, and they go to red. The biggest one is going to be the red. And what I can do here, I can change these colors, right? Or what I can do, if I double click to the gradient, I can add another color here as a blue. I can add another color here as another blue. Like the colors that you are pulling off is from here is not super clear, but if you see this menu here, color on the left, you can select a color on this menu by web or system or custom. So let's say slightly less greenish here, lime. And as you see, the left part of this point is lime, but the right still is blue. So I go to here and select it lime again. And like, let's say this one can be, I don't know, like this yellow, and this one can be this yellow, and we have something as such. And if I say okay to this, now I have more colors in, but that doesn't change much because you see we don't still have much of a curves here. So if I increase my number of my curves here, so let's put something like this, let's put something like this, let's put something like this, something like this. And if I organize these, selecting multiple curves, you see now I have way more colors. And obviously we can select these presets like, I don't know, red to blue. Obviously if I put start to the end and end to start, what I see is the larger one again is red, and the smaller one is going to be the dark blue, and the others would change in between. Obviously I can pull this pink over here, set one point, I'll put point in, And let's create an XY plane just to make sure. Put this guy here, and we can preview these all off. Okay, and the size of my, let's say, grids is this, and let's say, I don't know, like it's going to be too much, so let's maybe put 50 and 100 on Y extension. It's too much, overlap, so let's have something as such here. Okay, so these are my, you can see my grids. Maybe I can just go and scroll in top view directly, and this is my grid, right? So what I'm planning to have is to create basically sort of a attractor point, right? And if you remember from the previous exercises, what I can do is I can just group this with a scribble. I can say, or what I can do is I can put all this, well, let's keep it as such, with location. I can put this here, and I can put this all into one group. I can add this to this small group. Its location, and this is going to be with another scribble. I can say grid, and maybe I can decrease the size of this text, and I can add this to here. So now I know. And what we usually do is, as you remember, I create another point, which is going to be my attractor point. I draw this here, and this is my attractor point. And I can copy this text, put it here, attractor, and put this as my another group here. Maybe that group can be, at the end I'll group them all, obviously. So what we, if you remember, what we do is we grab the area of this cells, right, midpoint, and if I flatten this, now what I have is I do have my points here, and what I'll be doing is basically creating the distance in between, right? So what I'll be doing is, if I grab a component called distance, I can grab the distance between this point and this point, and I can use these points of distances to color my cells, right? However, to proceed with that, what I usually do is I come over to here, I say, if we want to change the sizes, you remember we put remap and so on and so forth, but now we don't need that. What we only need is we need bounds starting in the end point of these distances. And what I need further is to put a display, sorry, I need to go to prompts, under input, gradient, right click to this gradient, and let's switch it to this guy over here. And what I need to do, go to math again, deconstruct my domain, start is going to be my lower limit, and is my upper limit, distance is my parameter to create the colors. And if I connect this to display and preview, what I'll be seeing, let's check. Oops, that's not my geometry. My material is supposed to be that, and my geometry is going to be my color. But what I'm seeing here is, I see this, but this is basically, you see, this is basically curves, right? These are not the surfaces, but in order to create sort of a more fulfilling image, what I need to do is I need to convert these cells into surfaces or meshes, but this time we'll proceed with surfaces. So I go to surface menu. Under freeform, I'll grab a boundary surface. Boundary surface is a component that takes the planar curves and converts them into surfaces. But since I do have a lot of surfaces here, it takes a while to create or form these surfaces in. So it's probably gonna take a couple of more seconds, maybe longer than that, but I'm still waiting. And these surfaces are going to be previewed all in red. So what I'll be doing is I'll be creating or taking all these surfaces and converting them into colors that I'm previewing or that I'm showing you here. But let me pause the recording for a second here, or let's just wait. I'll just cut this part. Unfortunately, my screen just freezes to create these surfaces while I am recording my whole screen. So let's switch back to Grasshopper and see. So what we are seeing now here is basically these surfaces, right? And if it takes 3.4 minutes, by the way, it's a lot. So if I preview this off, and if I put this guy in here into my geometry, what I'm seeing now is based on the motion of this point, my surfaces are being recolored. Obviously, it's taking too much time, so why don't we just make this, I don't know, like something super simple, maybe 39 for this as well, and it probably will take another couple of, hopefully less than minutes, and then we'll see how it goes. Yes, now I think it's working a bit faster, so I can take this guy here in, and we can see that how our point is changing the gradient. Obviously, if we come over here and then preset this to this one, preset this to, I don't know, this guy, we see way more ranges in the color based on our attractor point. So what this point does is basically the more distance we have, the colors are ranging from red to red in this end, but maybe we can like use some other color gradient such as this one. You see, now it's from pink to I don't know, like red. And if you come over here and then make this into rendered view, you see changes. Or if you take this into, again, like shaded view, you see different colors. And what we are going to use here is component called, it's a native Grasshopper component, legend. And what this does, basically, based on a rectangle that you select, that you put in, it gives you a legend. And you have colors here, tags here. Tags are the information that you put in, colors are the colors that you put in. And if you right click to this, you can visualize it vertical smooth, you can visualize it horizontal discrete and horizontal smooth, or vertical discrete. So let's switch to vertical. So what we want to have here is basically to have this information, to have this color information and put it over here. But since we have like, I don't know how many colors here, we have 1,521 colors. If you put this in, we might be seeing problems. You see, there are problems with this one. So what we're going to do is we're going to use the same gradient. Let's grab a gradient here and let's put the same preset here. But this time we'll be using the colors based on the parameters. And the number of parameters we're going to put is the number of colors we're going to see here. So what do I mean? Lower limit as a default is 0, and as a default 1 for the upper limit. So for the parameter, if I create a series, number of series, that starts from 0, ends at 1, but if it goes with 0, 1, what I'll be having here is the number of series that has from 0 to 0.1. But what we can do here is it counts now at 10, but what we can do is we can put 11 so that we reach between 0 to 1. And this can be our parameter. And if I connect this here to my color, what you see is I see my colors that are put over here. But the problem with this one is it starts from 0 here. 0 is, in this case, refers to the top part of it. So what I'll be doing is I'll be putting a reverse here so that now it basically, the distance is smaller, it gets pinker, distance is larger, it gets red. But the problem is what I'm still seeing here is the 1 fish, 2 fish, this kind of stuff. So maybe I can put these guys here. It's not those here, sorry, to legend, my legend part. And what I need to do is I need to divide these values, the domain, between the same amount with my count so that I can plot that information here as well. So I go to math, underneath domain, I'll grab divide domain. And this is my domain to be divided. And how many counts I'll be having it? 11. and you see I have 11 segments here. But if I put this here again, you see my tags are doing the other way around. So it's basically the smaller parts are red and the bigger parts are pink. So if I also reverse this list, I have what I needed, and this is my legend. And if we say right click to this vertical discrete, we have this discrete information. We can come over here and then see our information, and as you see, we don't have any kind of outputs here, but this is our legends in terms of like the visualization of the data. So one thing I wanted to test here, if I round these values, let's see what we are having, and you see they are rounded to the values that are already there, so we have to do another stuff to make them round, but we can just stick to this right now. And yeah, and that's pretty much what we are having. And let me group this as my legend. Here's what I'll be drawing here, and what I'm going to do next is basically having this, creating a surface this time, or a B-rep this time, and putting that B-rep's information, area information, on top of it. Okay, and to proceed with that, what I need to do, I have to put this curve in, set one curve, and when I extrude this curve, as you know, we are achieving a surface, right? On Z direction, let's say 1400. And this will have a particular area on top of it, right? This surface will have a area on top of it. And obviously we can use another surface, or we can use a surface that is created in Rhino as well, but I'll come to that part later on. So if I put area, what I'll be seeing here is the area of this geometry, right? And if I round this area, this is the round component to the nearest, what I see here is this, and this is the value. But since I'm working with millimeters, that's why I'm having this value too large, right? So this is basically not square meters, square millimeters, okay? Or millimeters square. So how I'm going to put this information on top of my work as a text. So what I need to do is to cast this area, or like the rounded version of it, let's say onto the middle part of this surface. So there are two ways to do this. And to proceed with that, we have to grab text information. And to go with the text information, I'm going to display, and under display menu, there's a tab called dimensions. And in this dimensions tab, we will be using text tag and text tag 3D. What are the differences? So the first thing about the text tag, it basically takes the location as a plane, so I can connect it here, and it gets the text as the text. And you see now I am seeing the text here as well. But this text is a bit like off, but the good thing about text tag, it basically orients the plane based on your camera. So you always have this information that is projecting directly to your view, so we know what this is. And we can put a swatch here, and we can connect a swatch here, right? And what this does, basically, it shows me every single information. And when I increase this, you see my area is being increased, decreased, and so on and so forth. I'm not going into the conversions because it's not super important here. Again, which unit you're working in Rhino is directly transferred to. So if you right click to this, you can say really small text, you can say really large text. It's completely up to you. But one thing I wanted to show you here is we can use more text values here. Like if I go to the text, under set, under the menu of set, I go to text, you'll see something called concatenate. Concatenate basically a component that receives text, and we can put more slots as we did in merge component, and we can connect this nearest value here, not that one here, and then we can say millimeter square. And if I connect this now, what I'm seeing this as my text, And if you right click to here and if you say separator, you can put a space as a separator. So everything that you're adding is going to be separated by a space. So let's put another test tag. You'll see that text tag is going to be added with a space to this guy over here. What is the difference between location, or sorry, text tag 3D or text tag or tag 3D? This one actually requires a location with a plane. So if you put an XY plane, and let me preview this off for a second, it will create that text onto here, but you see it's super small. Size can be arranged with a numeric value. So if I put 250, you see something really large, but you see it's based on XY plane. You can put a color here. You can say this color can be, again, another color watch. Let's clear this space a bit better. So again, it can be white. Justification is, it's basically the location of the text on the plane that you're defining. So basically, if you right click to justification, you can say, if you say middle center, then your plane is going to be middle center of your text. If you right click and then say bottom right, then you'll see that your plane is going to be bottom right point of your text. So proceed, in order to proceed with that, I go to vector and underneath grid, I'll grab a populate 2D component. And populate 2D component generates this on 0.0000, but I need something over here. That's why I'll be creating a region. That's a rectangle. Very like set one rectangle, and let's create a rectangle here. And you see it already generates 100 points in seed one and number of or original points if you have any. So this is my region. Let's say we have 100 points. Let's say 50 points here. And seed is basically the trigger of the randomness. So if you put, I don't know, like 102, you see it generates this random pattern or random location for the points as you move through the slider. And you can define your pre-existing points or organization here as well, but we don't need that. So the good thing about this is we have 50 points here. And what I can do is I can create a random value. So if I go to set, under list, I can create, under sequence, I can create random. Random is a component in which we create random values. So it requires a range, it requires number of random values, and a seed, which again changes the randomness in a sense. So let's say we are going to create a range of, we can create a domain in between like 100 and I don't know, 2000, okay, and then put it over here. And then the other thing, the next thing that I'll be doing, how many numbers we are having. So we can connect this count to here as well. Whenever we have, like if we have, for instance, 26 points, we will have 26 random values. They are all connected to one another. And seed can be, I don't know, seed can be this time different, let's say 200. And if I pull out the panel here, what I'm seeing is the different heights. But obviously it's creating these as like numbers with some decimals. I can just type round and round this to the nearest values so that I always know how to proceed with this. And the next thing, how I am going to use this information to create lines, right? Because my line's supposed to be created by this points, and let's say we are creating lines on Z direction, or like we are creating lines going towards the sky. So if I go to curve, and under primitive, I'll grab line STL. Line STL is a component where you see three inputs. First is the start, which is our points. Second is the direction. The direction is going to be Z in our case. The third is going to be the length, which we are using the nearest values. So if you take a look at these lines, now what we see is we are having lines that are in different heights, random heights. So if I pull, I don't know, like 100 lines, and maybe if we crank this up a bit, what we see is we have lines that are changed here in terms of their heights. And if we change the locations, we can change the locations, or we can change the distribution. So if I preview this off, what I'm seeing here is lines that are created on top of our points. So how I can extract this information of the lengths on top of these lines? So what I can do here is basically I can grab what can be useful in this end is maybe to get the endpoint of each line. So we are going to plot the text on top of each line. So I can grab my endpoints, and we have start and endpoints here. Why it's extracted both? Because this component takes out the lines or the curves starting and the endpoints. If I go to display, if I go to preview, dot display, under dot display, what I can have is I can have the endpoints, okay, and the color is black now. I can put a color swatch to change this. And if I zoom in, you see, I see the points, but they're too tiny right now. So what I can say for the size is, I don't know, let's say 50 to see. I mean, we are seeing it, but it's a bit off. So let's make it a bit larger. So we now know where to plot the information. And if you right click to it, it says lazy and greedy. Well, I mean, these are the types in which we show different points, I think, but I don't know the difference, to be honest. So this is our point visualization in which we are going to plot the length or height information. The second thing is we are going to use again the text tag, and our locations are these points, and our text is going to be this nearest. However, we want to concatenate this with height, right? So what we can say instead, starting with this, and let me plot this over. Okay, what do we see now? We are seeing these values, right? We are seeing all these values. And if I pull out a swatch, color swatch, let's make it bluish this time, okay, and put it over here as my color. You see, yeah, it's too blue now. Something like this maybe, okay. And what we can do next is to provide why are we using starting with this. What we can do is we can start maybe putting some different information. For instance, what we can type is height and putting it at the beginning of this text fragment. Put this one next. You see, now what I'm doing is I put the height and then I put the information right next to it, and then I can say adding another slot and then put millimeters. Now this means height is for each line is plotted over, and we can see, for instance, if I zoom in, height for this one is 755, for instance. Okay, so and obviously if I create this seed, if I change the seed, we see things are being changed, or changing this, things are being changed, things are being changed, so on and so forth. So we'll be using pretty similar things. So grid location this time is going to be this guy, and maybe it's even a tractor point as a group. I can copy it and paste, put it over here, and put my tractor point in. What I do usually, as you know, is pull out the distance in between, and this area of this cell, obviously the midpoint of this cell, and my attractor point. And based on this, what I'm doing is, as you know, is provide some information here, right, on top of each and every cell. In this one, what we did is we visualized the colors based on the distance, and we create this legend right next to it. But this time what we can do is plot that information like as a text on top of these cells. And to do so, what I'm going to do is I'll be putting this time tag 3D, and the location is going to be always XY plane on this cell organization or on this grid. Maybe I can go top view Okay, and preview this off maybe, and you see planes are on top of every single cell. This is the location, and this time in order to create the text, what I can say is concatenate, and concatenate. This time I can type distance to, and then I can go underneath the distance to attractor point and create this here. This is my first text. The second is obviously what I'm doing is rounding this information because it will save up some space for me, and I can put this in. And the next thing is I'll be putting a millimeter unit by creating this slot in. So if I put this guy in here as text, it's obviously taking some time to calculate this, but we started to see text information here, but it's pretty small. And if I justify this by middle center, you see my text is going to sit on top of my plane in the middle. So preview this off, and if you put the size, let's say 50, you can see, maybe we can see visually a bit better information, but 50 is too much, so 30 maybe, too much, 20 maybe, and 15, you see. And what we can say is the color, we can put a swatch, and we can say white. And what I'm going to check here is what would happen if why don't we do something like this? Let me pull out this point here, because we are losing some space and time here, because there are too many cells inside of this organization. So why don't we go with like 10 by 10? Things will be faster. And why don't we have like, I don't know, 500 for every single cell? Now what I'm seeing is maybe I can view this a bit better, you see, and maybe top center might be, oops. Sometimes it's weird though, based on the plane. So what we can say, bottom center is the right one for this. So what I'm doing is, if I change this, you see my text is being changed each and every time. So imagine if you're trying to come up with a solution for the view or for the distance in between plots, I think this can be really helpful.